Assalamu alaikum. In this video, I will explain Lecture 2 of Math111 لطلاب السنه التحضيريه بجامعه الامام عبدالرحمن بن فيصل القسم العلمي. في هذا اللكشر راح أناقش 1.2 اللي هو Real Numbers and Basic Arithmetic Operations. Those are the subtitles that I will talk about in this lecture. Sets of numbers, the definition of sets numbers. Sets of numbers like, for example, the natural numbers. The natural numbers denoted by n, and it start from 1, 2, 3, and so on to the infinity. Okay. Then after that, we have the whole numbers. And in the whole numbers, we add a 0 to the natural numbers. So the set would be 0, 1, 2, and so on. Then we have the integers, and this is the samples of integers, z. And in this sets, we add the negative numbers to the whole set, and we get the integers numbers. So basically, the integers are the positive numbers, 0, and the negative numbers. Then we have the rational numbers, and in the rational numbers is the ratio between the ratios of two integers, a over b. So if any numbers, I can write it in a fraction form, I will call this rational numbers. And this is the samples of the rational numbers. It's a Q. So it is R such that R equal A over B, and A and B are integers numbers, and B does not equal 0. And this is so important in math, that B does not equal 0, because the value 0 in the denominator make the number or the expression undefined. Okay, so this is such an examples of the rational numbers. We have this one is a rational numbers, since we have in the numerator we have an integers, and in the denominators also we have integer. Also 2 over 21 is a rational numbers. 3 is a rational number because the denominator here is 1. Okay, so any numbers has no denominator, it means that the denominator is 1, but we usually do not write that one. Okay, so in the number line we have the real numbers. We have some numbers that are not included in the rational numbers. Those numbers are the irrational numbers. Okay, for example, we have pi, we have root of 7 or negative root of 7. Those numbers, we can't express those numbers in the form of fraction or in the ratio form. So in this case, those numbers are not rational numbers. We call those kind of numbers the irrational numbers. Okay, so the irrational numbers are real number but not rational. Okay, so we can express that in the set builder notation. So it is x such that x is a real number, but x does not belongs to the rational numbers. The example is root 2 and pi. Root 2 and pi are examples of the irrational numbers. As we said, if you put the value of pi in the calculator, you will have a numbers that is 3.14, and then different numbers to the infinity. So we can't express that number in fraction form. Also, root 2 is rational numbers because we can't express this one in the form of numerator or denominator, or we can't get an integers from the root of 2. Okay, so you can imagine in natural numbers is this set, and it's inside the sets of whole numbers, because in the whole numbers we have 0, beside this group. Then we have the integers, which include the whole numbers and the natural numbers and also the negative numbers. And we call this set as in the integers. And then when we include this all beside the numbers that is in the fraction, and the denominator does not equal 1, so this is the rational numbers. Those numbers are the rational numbers. And we said that the real number is either rational or irrational. So there's two types of real numbers, either rational or irrational. And the irrational numbers include the numbers that we can't express them in the form of ratio. So like for example, root 2, root 15, negative root 8, pi over 4. So basically, as you can see, the natural numbers is a subset of the whole numbers, and the whole number subset of the integers, and the integer subset of the rational, and the rational subset of R. Okay, and since R is either rational or irrational, so if we have the union between the rational and irrational, we will get R. And since the numbers of rational and irrational are totally different, so the intersection between rational and irrational would be phi, because the number can't be rational and irrational at the same time. Okay, we have an example here. Determine whether the statements are true or false. Every integer is a rational number. Okay, so in this question, it says that every integer, so z, is a subset of the rational, which is q. And we saw that before, and basically we can just again say that all the numbers of z, which is the negative numbers, negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on, are actually rational numbers, because the denominator of those numbers are 1. So we could write those numbers in the rational form. So all those numbers, all these sets is actually a set of rational numbers. Okay. Next question, the number pi is a rational number because pi equal 22 over 7. And actually this is not quite right, because pi does not equal 22 over 7. Pi is almost 22 over 7. This is an approximation of pi, okay? Because when we if you just try to put this in the calculator, you will see that 22 over 7 equal 3.142857429, but pi pi is different. It has the value of pi is 3.141592656. Okay, so as you see, we have different value, but it is approximate value of pi. So this is false and this is true. Every real number can be written in a decimal notation, and this way is called decimal representation of the number. So for example, if we have 3 over 4, if we divide 3 to 4, we will have here 0, and then decimals, we put 0 to the 3, and then we divide 3 to 4, we will have 7. 7 times 4 is 28. Then we subtract these two numbers, we will have 2. So 2 is not divided by 4, so we add 0. 20 divided by 4 equal 5. 5 times 4 equal 20. Then we subtract, we will have 0 and 0. So as you can see, 3 over 4 is written as 0.75. Also, if we do the same things to 7 over 3, we will have 2.333. But the special things here, as you can see, the 3 is continuous to the infinity. So I can write this also as 2.3, then I put dash above the 3 to represent that 3 is repeated to the infinity. Okay, so those two numbers, or those two types of numbers, are actually belongs to the rational numbers. Okay, belongs to the rational numbers. Let's see root 2 and pi, and we already said that root 2 and pi belongs to the irrational numbers. And you can see that root 2, if we put this root 2 in the calculator, we will have these values, and this ellipses represent that those numbers are continuous without specific pattern. As you can see, there's no specific pattern for those numbers. They are changing to the infinity. And also pi, 3.14, 15, 9, 2, and so on, and they are changing to the infinity. So there is no specific pattern for those numbers after the decimals. That's why those two kinds of numbers belongs to the irrational numbers. Okay. So numbers such as this one and this one are called the terminating decimals. So if we do the long division and we have 0 in the remainder, that means we have limit numbers after the digits. That's why we call this kind of numbers terminating decimals. But numbers like this one and this one, where we have specific patterns and those is repeated to the infinity, we call this as repeating decimals. So here we have 0.3 and 3 is repeated forever, and this also 3.7, then 5.4, 5.4, 5.4, as so on. So I can put dash above 5.4 to represent that 5.4 is repeated to the infinity. Okay, so decimals representations of real numbers. The real numbers has two types of decimals representations, as either repeating or terminating. Okay, and those are types of the rational numbers, or irrational numbers if and only if they are neither repeating nor terminating. Okay, so if it's not this type and not this type, those would be from the irrational numbers group. In these examples, we want to put check in the box if the number is an element of the set at the top of the column. So we're going to check set by set. First, let's see which of those numbers are real numbers. The real numbers so far are everything we talked about, except that this form of number, and we call this one the imaginary numbers, okay, or or the complex numbers. So since here we don't have a negative value inside the square root, so we can say that this one is real numbers, and also the rest. Okay. Now let's see the rational numbers. Rational numbers, every number I can write it as a over b, where a and b are integers. So negative 3, I can write negative 3 as negative 3 over 1. So yes, it is rational numbers. 22 over 7 also rational numbers, because I could write it's written as a over b, and 22 and 7 are integers. Negative pi is not a rational number because pi is not a rational number. Okay. And 3.14 is a rational numbers because it is, we said that the rational numbers is either repeating or terminating. So this is a kind of terminating. And this one is not repeating nor terminating, so it is not a rational number. For this one, it is a rational number, yes. Okay. And this is a kind of numbers that is repeating, because we have a dash here above the 6, which means we repeat 6. to the infinity. So yes, it is a rational number. And in this one, it is 75. Okay, and 75, we can write 75 as 75 over 1. So yes, it is a rational numbers. Since the rational and the irrational numbers are totally different, the intersection between them is phi. So if the number is rational, it will not be irrational. So we just can put here x, check, x, check, x. Okay. Now let's check the integers. The integers, of course, if the number not rational, so it will not be integers. Okay, so since here x, so also here x. And also the whole is not. Okay, because as you know, the whole numbers are subset of the integers, and the integers are subset of the rational. Okay. So that's why if the number is not rational, it will not be integers or whole. Now let's see the -3 if it's integers. Yes, it is integer because as you know, the integers are the negative and the positive of the natural numbers and also 0. Okay, 22 over 7 is not integers because 22 is not divisible by 7. Okay, what about 3.14? It is not integers also since we have the decimal. And for this value, this number is divisible by 11. So yes, it is integer. And you can check that if you divide, if you do the long division. You could do the long division or also you could check the divisibility by 11. So let's do this. 13 divided by 11 is 1. 1 times 11 is 11. I subtract. I'm left with 2. Then I put the 3. 23 divided by 11. 2. 2 times 11 is 22. I subtract. I left with 1. Then I put this 1. So I have 11. So 1 times 11 is 11. And the remainder is 0. So I have 121. This is 121. So yes, it is integer. What about this value? This value is not integer since I have the decimal. Okay, and the last one, 75. 75 is integer. Okay, if the number not integers, it would not be whole also. Okay, so here I put x and here also. So I left with -3. It is whole? No, because you don't have negative values in the whole numbers. So this is no. And here, is that whole? So also, yes, since here no, so it would not be also whole numbers. 121, is it whole? Yes, it is whole numbers. And also 75 is a whole number. Okay. Definitions and properties. We have basic operations on real numbers like the addition, the multiplication, the subtraction, and the division. Okay, if I have, for example, A and B, two numbers, I can add them and say A plus B or A times B. And I write this as AB. I don't have to write the cross thing. Okay, we just put the numbers next to each other, and that means I times them. And A minus B, and then A over B or A divided by B. We have also variables, and variables. If you don't know the values, you just use samples of the letters. Like this, and this means we have variables or unknown value. Algebraic expressions is used numbers and letters and the operations. This is an example of algebraic expression. We use the variables and we use the addition. And here we have also another algebraic expressions. We have numbers, letters, and negative, and plus, minus, and divide. So any operations that gather two values together, we can call this an algebraic expression. The sum of real numbers, for example, x plus y, and we have also the commutative law of addition. What is the commutative law of addition? For example, if I have a plus b, I can write it as, or it has the same value as b plus a. So the commutative law of additions means that I can switch between the values of a and b, and in this case, I call this law is a commutative law of addition. The associative law of addition, when I have three values, a, b, and c, and I have, since addition, so I want to add those together, I can add the first two, then I add it with the third one, or I add the last two, then I add it with the first one. This gives me exactly the same value, okay? The additive identity, what is the identity in the addition? It is 0, which means the value that I added to a number and give me the same number. So 0, if I add it to the number from the left or from the right, it will give me the same value. It will not change the values or the result. And the additive inverse, so what is the value that I added to x to give me 0? So if I add negative x to x, it will give me 0. So negative x is the additive inverse. The difference of real numbers, it's x minus y. Indicate whether the following statements are true or false. The subtraction is commutative and the subtraction is associative. So we already said that the addition is commutative and also associative. And for the subtraction, let's check x minus y. It is commutative, so it means is x minus y equal y minus x? Of course not. Okay, and take an example. 2 minus 1, does it equal 1 minus 2? You know that 2 minus 1 equal 1, but 1 minus 2 equal negative 1. And we know that 1 does not equal negative 1, so false. The subtraction is not commutative. Okay, so it is associative. Let's check three numbers, 1 and 1 and 1. And in the first case, I will add the first two, then I will add it to the negative 1. So 1 minus 1 equals 0, 0 minus 1 equal minus 1. And in this case here, this 0, then 1 minus 0, and 1 minus 0 equal 1. So negative 1 does not equal 1, so it's not associative. Okay, now let's talk about the definition and properties of the product. If we have a times b, we can read that as a times b or a multiplied by b. And the result, for example, if I have 3 times 4, the result would be 12. We can see that 4 is a factor of a 12 and 3 also is a factor of 12. Okay. The commutative law of multiplication, if you remember the commutative law of addition, a plus b equal b plus a. So for multiplication means a times b equal b times a. So there is no problem if we switch between the numbers. Okay, we will have the same result. And the associative laws of multiplication, it's a times b times c equal, okay, a times b times c. So if you multiply these two together, then we multiply the result with c, we'll have the same answer if we multiply b and c together, then we multiply the result with a. Okay, so now if we have an example, apply the commutative and the associative laws of the multiplication to multiply these three numbers. So let's see, we want to use the commutative law first. So I will multiply 2 with 5. So I will switch. So the commutative is about switch the numbers. So I'm going to multiply 2 times 5, then I multiply 1 to 9. Okay, so here I use the commutative by switching the numbers. Now I will use the associative law. When I multiply these two numbers together, then I will multiply the result with the third number. 2 times 5 equal 10 times 129. And you know that 10 times 129, we put the 0 down and we times 129 with 1. So we will have 129, 1290. Okay. Okay, now what about the identity and the inverse of the multiplication or multiplicative? So the identity would be number 1, since if I multiply 1 with any number, I will have the same number. And the inverse would be the reciprocal of x. Okay, so if I times x with its reciprocal, I would have the identity. So x times 1 over x, I will cancel x with x, then I will left with 1. Okay, and be careful here that reciprocal does not equal 0 because it is in the denominator. Okay. And we have also the zero factor property. And in the zero factors properties, if I have any two numbers, the product of any two numbers equals 0, then either the first one equals 0 or the second one equals 0. Yani of course, two numbers, if I times them, I will get 0. So it has to be one of them, has to be equal 1. Okay, so that's why we use this kind of properties to solve equations in the coming chapters. Okay, so let x be a real number, and we have x minus 1 times x plus 1 equals 0. What is the possible value of 0? Let's use the zero factors properties. So by using these factors, I have this value times this value, two values. The product of these two values equals 0. So either the first value equals 0 or the second value equals 0. Now we use what we learn, and now we said that what is the number or what is the inverse of -1? The inverse of -1 is 1. So x equal 1. This means what is the inverse of -1? The -1, the inverse of -1 equal 1. And here also you can ask yourself, what is the inverse of 1? So the inverse of 1 is -1. So the possible values of x would be 1 and -1. Okay, the distributive law of multiplication over addition. What is the distributive law? يعني خاصية التوزيع. Distributive توزيع. Multiplication over addition. توزيع الضرب على الجمع. So let's see, we have this a times b plus c equal this one, and we want to use the distributive law. Okay, so this would be a times b, then plus a times c, as you can see. Okay, and this is at the left distributive, since a is on the left side, and the same things here. We will distribute c to the both values inside the parentheses. So it would be a times b, then plus, sorry, c times b, then plus c times a. Okay, and this is the right distributive, since the value that I will distribute is located on the left and the right side. Okay. So let's use this distributive in these examples. I have 5 times x plus 4. So I will distribute 5 to x, then to 4. So this would be 5x, then plus, then 5 times 4. So this would be 5x plus 20. Okay, now b, 2 plus x times x, same things. I will distribute x to both numbers inside the parentheses. So x times x equal x squared. Then I put the operation inside the parentheses, which is plus, then x times 2, which is 2x. Okay, let's see C, 2x plus 3, 3x plus 2. Okay, now I will distribute, I will start with this, so I'll distribute 2x, okay. So 2x times 3x, then plus 2x times 2. Then I put this plus, then I will distribute 3 times both values here, 3 times 3x, then plus 3 times 2. Now, let me just simplify. 2x times 3x is 6x squared plus 2 times 2 equal 4x, then plus 3 times 3 is 9x, then plus 3 times 2 equals 6. I can simplify this even more by adding the similar terms together, which is 4x plus 9x equal 13x. So this would be 6x squared plus 13x plus 6. And that's it. Okay. Properties of negative. If a and b are real numbers, then negative a equal a. It's just multiplying this negative together, and you know that negative times negative equal positive, so that's why we will get a. Okay, and here negative 1 times a would be negative a. Okay, and this one negative we will times the negative together, and a would be together. So negative times negative is positive, and a times b is ab, but since it is positive, we don't have to write positive, we just write AB. And here we times A with B together, and then we put the negative outside, okay? This is same if we write a negative A times B, or A times negative B, or negative AB, it's all same values. Okay, and just be careful, you don't, in the product, of numbers, even if you have a parentheses, you don't distribute any values, okay? And you don't say, for example, here, this is equal CAB, okay? We do not distribute the multiplication to the multiplication. You just can ignore the parentheses and write the value and write the multiplication without a parentheses. Okay. Evaluate each of the following expression. We have in A, negative 2 times 3. As we said, we have 3 numbers here, look like 3 numbers here. Negative 1 times 2 times 3. And this is just, we can just times the numbers together and put the negative down below. So 1 times 2 times 3 equal 6. And in B, same things. I will times the negative with the negative. I will get positive. And then 2 with the 3 equal 6. C, I will times the number together. So 2 times the 3 is 6. And then I'll put the negative as it is. Then D, the negative times the negative is positive. So I don't have to write positive. Then I put the number. Okay. Then I have E. Okay, this negative 2 to the power 2, it means negative 2 times negative 2. So I'll times the negative with the negative, it equals positive, then 2 with 2 equal 4. So be careful, there's difference between this one and this one. Here the square is to the all values, negative 2, but here negative has nothing to do with this one, so with the square. So this look like negative 1 times 2 to the power 2. So 2 to the power 2 equal 4, then I'll put the negative as it is. Okay? And then we have G. I will times the negative together, so negative times negative is positive, then I will left with 1 negative. Then 2 times 3 is 6, 6 times 4 is 24. Last, H. Same things, I will times the negative together. Negative with negative is positive, and here negative with negative is positive. So I will not write any sign here. Then 5 times 2 is 10, and 3 times 4 is 12. Then 10 times 12 is 120. So the answer is 120. The distributive law of multiplication over subtraction is the same as the distributive law of multiplication over addition. The difference only here that we have negative in between B and C. So for A times B minus C, we distribute B to both value. So AB minus AC. And this what we call the left distributive law because A located on the left of the parentheses. For the right distributive law, C is located on the left of A minus B or of the parentheses. And same things, we have to distribute C to all the terms inside the parentheses. So C times B, then minus C times A. Okay, in example, remove the parentheses from the following expression and simplify. We have this 2 times 2w minus 5. So I'm going to distribute 2 to both terms inside the parentheses, 2w, then I put the negative, then 2 times 5. Okay, so I have 2 times 2w, then minus 2 times 5, and 2 times 2w is 4w. Then I put the negative, 2 times 5 equal 10. Okay, for B, I have 2 parentheses, and in this case, I have to be careful which one to distribute. You can distribute the terms on the first parentheses, or you can distribute the terms on the second parentheses. So let's see here, we want to distribute x to both value, then we will distribute negative 7 to both value. Okay, so as you can see here, I put x, then the parentheses as it is, then a plus, I put negative 7 times the parentheses. Now I will start to distribute x, so x times 2x, then x times negative 3. And in this case, I will distribute the negative 7, so negative 7 times 2x, then negative 7 times negative 3. Now I just complete simplifying. Here we have 2 times 2x is 2x squared. Then negative 3x, I'll put it as it is. Then I have here negative 14x, and here negatives times negative is positive. 7 times 3 equal 21. Now I'll try to combine the similar terms together. I have here x and here x. So negative 3 minus 14 is minus 17x. So since I just distribute the values, I don't have to put the parentheses. I just delete it, okay? Simplify the following expression. I have 4x, then minus this parentheses. And in this case, I have to distribute the negative. So if the negative out of the parentheses, I just go inside the I just delete the parentheses and turn the sign of the numbers. If the numbers is positive, I put it negative. If it's negative, I put it positive. So as you see, I put this value as it is, then 3 I put it as negative 3, and negative 4x I put it as plus 4x. Okay, so if we times the parentheses with a negative value, it means it will change the signs of all the terms inside the parentheses. Now I have to just add the similar values. Here I have 4x plus 4x, which is 8x, and negative 3 I just put it as it is. For this one, same things. I have negative 4x, then I have negative, then a parentheses. So I just have to distribute the negative value to all the terms inside the parentheses, which means I will change the sign of the numbers or of the terms inside the parentheses. So negative 4x, then 3 turns to negative 3, and 4x turn to negative 4x. Now I add the similar values together. We said negative 4x with negative 4x equal negative 8x, and I put negative 3 as it is. Now let's try and check this question. Simplify the following expression. So same things. I have 5y, so I'll put it as it is. Then I will distribute negative 5 to negative x, and then negative 5 to negative y. So negative 5 times negative x, then negative 5 times negative y. Again, so I'll put 5y, and I will do these operations. Negative 5 times negative x is a plus 5x, and negative times negative is the same thing, is a plus 5y. So I'm going to add this 5y with this 5y, so I will have 10y plus 5x. For the second question, 5y, then I will distribute the negative, so I will just change the signs inside the parentheses, and I will remove the parentheses. So it would be plus x minus y. Now I will just add this y with this y and put x as it is. So 5y minus y is 4y plus x. Computing with a fraction, division of real numbers, we have a over b, and we can read that as a divided by b or a over b. Okay, this form of numbers is called also a fraction. If I have a over a, 0 over a equals 0, it means a does not equal 0. Okay, and a over 0 is undefined. Okay, we can't have 0 in the denominator. This is undefined. If we have a form of a fraction and we want to get rid of a fraction, we can use this equivalent. So a times d equal c times b. This is a cross multiple. So we can now subtract cb from both sides. So ab minus cd equals 0. We can also, if we have ac over bc, we can cancel c from the numerator with the c from the denominator, and we're left with a over b. Okay, so a divided by c over b divided by c equal a over b, and we always put this condition. If we have a number in the denominator, we just say that c does not equal 0. Determine whether this value equal this value. Is it true? Okay, so of course these two values are not true because it seems like they cancel this 3 with this 3. And this is wrong because the value in the denominator is not in the form of factors. Okay, they are. We have two values here, and there is addition in between, so we can't cancel numbers from up with the numbers from down. Okay. Okay, so what should we do? Let's say, for example, we have 3 root 2 over 3 pi plus 3. In this case, I can take 3 as a common factor. Then I will left with pi plus 1. So if it's look like this, I can cancel this 3 with this 3. Because here I have two factors. Okay, there is a multiple in between. So I can cancel one of them with the one of the values in the numerator. And I left with root 2 over pi plus 1. We also can check by using this expression. So if we times this together, then we minus them from this together. We have to get 0, but as you can see, it equals 2 root 2 and does not equal 0. We have sum of two fractions. We have two cases in the addition of two fractions. The first one, if we have the same denominator. So if we have the same denominator, we just put the denominator as it is. Then we add the numerator. So a plus c. In case we have different denominator, so we have to just multiply this two together, then put this operation, then we multiply this two together, and in the denominator we multiply this two together. Okay. Opposite of a fraction, so a over b equal negative a over b and equal a over negative b. So the negative, I can put it out of the fraction or in the numerator or in the denominator. This is totally same. Difference of two fractions is exactly same as the addition or the sum of two fractions, but the difference here that we have minus between the a and c. Okay, the reciprocal of the fraction, if I have a over b, the reciprocal of a over b, okay, is b over a. So the reciprocal of 2 is 1 over 2 because the denominator here is 1. So all you have to do here is to flip the fraction. The quotient of two fractions, so a over b divided by c over d, you have to keep the first fraction as it is, then change the operation from division to multiplication, then flip the fraction cd to dc. Now you just times two fractions, and in timesing two fractions, we just time the numerator together and the denominator together. So AB divided by DC. Of course, here all the values in the denominator does not equal 0. Okay, so C, B, and D does not equal 0. Perform the indicator operations. Write your answer as single fractions and simplify as you can. Do not use calculator. So we have here some questions, and since this is already solved, I will skip this part and do this one with you. Okay, let's check 1 over 3 plus 1 over 2. In this case, as you can see, we have different denominator. So I will times this together. 1 times 2 is 2, then plus 1 times the 3, which is a 3, then over 2 times the 3, which is 6. So I have 5 over 6. Same things here, but I have negative instead of the positive. So same things. 1 times the 3 equal 3, then minus 1 times 2, which is 2, then over 3 times 2, which is 6. So I have 1 over 6. Okay, in this question, I have different denominator, but since I can just, if I times this one, the first fraction with the 3 up and down, I will get the same denominator as the second fraction. So the new fractions I will have is 3 over 27 minus 2 over 27. So here I don't have to change both fraction. It's enough to change only one fraction to get the same denominator. So this equal, now I have the same denominator, I will put 27, and then I minus the numerator. So the answer would be 1 over 27. Okay, D. We have different, here we don't care whether we have different denominator or same, because we have multiplication. In multiplication, we times the numerator together and the denominator together. But it's better for you, since it says simplify, it's better for you to simplify first, then times, okay? Because if you times first, you will get a large number, then you have to do long division. And to avoid doing long division, you first simplify. See, here we have 14, and 14 is 7 times 2. So you can cancel this 7 with this 7. So you're left with 2 times 2, which is 4. And in the denominator, we have 3 only. So same things here. 14 is 7 times 2. So I can cancel this 7 with this 7. So I'm left with 2 times 2, which is 4, and 3 in the denominator. I have one negative, so I can put it here, or I can put it beside the 4, or I can put it beside 3. Okay. Now we have here subtraction. You know that the denominator here equal 1. So I can use the 5 times 5 is a 25, then minus 1 times 1, which is 1, then over 5 times 1, which is 5. So the answer is 24 over 5. Okay. You know this here, the denominator of A is 1. So in the division, we keep, change, and flip. So 1 over 3, if we flip 1 over 3, we will get 3 over 1 or 3. If the denominator is 1, you don't have to write it. So A times 3, this is fine, but we usually, if it's one variable times a number, we write the number, then a variable without the operation. And this means 3A means 3 times A, or A times 3. Okay, for this one, 1 over 3 divided by A, we do the same things. We keep the first number, change the operation, then flip the second number. Now, A over 1, if we flip it, it would be 1 over A. So all what we have to do here is to times the numerator together. So 1 times 1 equal 1, and times the denominator together. So A times 3, or 3 times A equal 3A. Okay, for I, we have negative times negative is positive. Now the 14 is 7 times 2, so we cancel this 7 with this 7. Now we're left with 2 times 2, which is 4, and 3 over 3. In J, we have 2 over 7 divided by 14 over 3. So we will keep the first fraction, change the operation, flip the second fraction. Now we can also simplify. 14 is 2 times 7, so I'll cancel this 2 with this 2. I will left up with the 3, and down 7 times 7, which is 49. Okay, in K, I have negative divided by negative, which is positive. Then I will keep the first fraction, change, and flip. You can write this as 2 over 1 or 2. So you will times the upper part together, and then we times the bottom. So 1 times 2 equal 2 over 3 times 1 equal 3. So the answer is 2 over 3. Okay. Here the same things. This the denominator of 3 is 1, so I'll times the 3 with 5, which is 15, and 1 with 7, which is 7. So the answer is 15 over 7. Okay, the exponential expression, if I have a to the power n, this means a times itself nth times. So I'm going to keep going, timesing a with itself, okay, nth times. And I call a as the base and n is the power or is the exponent. And this expression is an exponential expression. We read a power 2 as a to the power to the second power, or a square, or a to power 2. Also, a to the power 3, I can write it as a to the third power or a cubed. A to the power n, I can read it as a to the nth power or a to the nth. Now we have some examples here. 1 to the power 3 equal 1 times 1 times 1 3 times, and it equals 1. And negative 2 to the power 4 is negative 2 times negative 2 times negative 2 times negative 2. As you can see, 4 times, because the power is 4. And now we have this negative will cancel this negative, and this negative will cancel this negative. Then I will times 2 with itself 4 times, which equals 16. Now be careful here. This negative is included inside the parentheses. So it looks like negative 2 to the power 4, then 2 to the power 4. And you know that negative 1 to power 4 equal 1. So the negative usually is disappear when the power is even and remain when the power is odd. But in this case, the negative is not included to the power. Okay, this look like negative 1 times 2 to the power 4. So the negative will stay, and then I find 2 to the power 4, which is 16. Grouping samples. By grouping samples, we mean the parentheses. We have a parentheses, this shape, and we have a brackets, it's like square, and we have a braces, and this is for the set, and we have a fraction bar, okay, like A over B. This is the fraction bar. Now, what is the order of operation? If you remember the phrase, please excuse my dear Aunt Sally. So we means that we start with the parentheses, then exponent, then multiplication and division, which one come first from left to right, then addition and subtraction, which one come first from left to right. Okay, let's have an example. Evaluate 15 plus 4 divided by 5 times 8 minus 6 minus 11 square. So I recommend you to do this always, even if it's easy. Always do it step by step so you won't miss anything. So first things we said, it's the parentheses. So we gotta solve whatever inside the parentheses. 6 minus 11 equal negative 5. So I'm gonna remove this value and put negative 5 instead of. And I put the rest as it is. I will not change anything. Now I finish the parentheses, so I have to do the exponent. So I'm gonna do this one. Negative 5 to the power 2 is negative 5 times negative 5, which is 25. So all I have to do, I will put everything as it is, and I will just remove this value and put 25. After the exponent, I will do the multiplication and the division, which one come first. So by reading this statement from left to right, we will face this one first. 40 divided by 5 equal 8. So I'm gonna just remove this one and put 8 instead of, then I'll put the rest as it is. Now, read this statement from left to right. you will see that you have the multiplication, 8 times 8. So just remove the 8 times 8 and put 64. And just put the rest as it is. Now we have, in this one, we have addition and subtraction. So we could do the addition first, or the subtraction, doesn't care, because you will take every number with its sign. So 15 plus 64 equal 79, then minus 25, which equal 54. Okay, here we have an example. Remove all the parentheses over here, which means we just simplify. Okay, so we have here, as you can see, we have negative 2 and times 3x minus 2y plus 7 plus 3 times this one minus 7 times this one. So in this case, we have many parentheses and many brackets. Okay, we just start from the inside, okay? So we gotta start from this 3. We'll distribute this 3 to these two values. Then we will distribute. We will solve this one. There is no meaning here for the parentheses since we have a plus. Then we will distribute the negative 2 to x and negative 3. So 3 times x is 3x, then 3 times negative y is negative 6y. I put plus 7 as it is, and I put this value as it is, and I put those brackets as it is. Now we just add this plus 10 with 2, okay, or just remove the parentheses. And in this case, I will distribute negative 2. So negative 2 times x is negative 2x. Then negative 2 times negative 3 is a plus 6. Then I'll put a plus 5 as it is. Okay, now look carefully at this one. Here we have negative 2. We have to distribute it to the values over here. And then we have a 3, and we'll distribute it also. And we have negative 7, we will distribute it also. Okay, before we distribute the values, let's simplify what inside the parentheses, okay? So if we, the first parentheses or the first brackets is already simplified because we don't have similar terms. We can't add different terms together. But in this case, I can add 2 with 10. And this one, I can add 5 with 6. So by adding 2 with 10, I will get 12 minus 5x. And here, 11 as a value for 5 plus 6. So the rest, I'll put the rest as it is. Now, I will distribute the negative 2, and I will distribute those values, the negative 2 and the 3 and negative 7. So by distributing the negative 2 times 3x is negative 6x. Negative 2 times negative 6y is plus 2y. Negative 2 times 7 equal negative 14. Now also we will distribute the 3 to 12 minus 5x. So 3 times 12 is 36. Then minus 3 times 5x is 15x. Now, negative 7 times negative 2, negative times negative is positive. 7 times 2 is 14, and then x. So, again, negative 7 times 11 is negative 77. So now, I'm gonna combine the similar terms together. Now, I have all the numbers or the negative 14 and negative 77, and also I have 36. So let's add those together. We will get negative 55, and we will combine the x terms together. Okay, remember to take the numbers with the sign next to it. So I'm going to combine those together. I will get negative 7x. And for 12y, there is no other terms of y, so I'll put it as it is. Okay, try and check. We have to simplify this expression. As you can see, we have many brackets, many parentheses, many braces here. So we have to do the smallest one to the large one. So here we have to distribute negative 5, and then here we have to distribute 3. We have to do this multiplication as in the first step. So let's start. I will put everything as it is. Then I will distribute this. It would be negative 5y. Then negative 5 times negative x is plus 5x. Since I finished distributing, I don't put the parentheses. I just drop it or delete it. Okay. Now I will distribute the 3 to 2x. It's 6x. Then 3 times negative 5 is negative 15. Now minus 7 times 2 is 14. Then minus 4. I close the parentheses, the brackets, and then I put negative 3, negative 7. Okay, now have a look again. What should we do? We have to do this addition. Okay, so I will just put everything as it is. Negative 5y plus 5x minus 2 times 6x, then minus 15 minus 14. Okay. Minus 15, minus 14, minus 4. Minus 15 minus 14 is minus 29. And minus 29, let me write that down. Minus 29 minus 4 is minus 33. So this would be minus 33, then minus 3, then minus 7. Okay, so now what should we do? We have to distribute this negative 2. Okay, so minus 2 minus 5y plus 5x, then minus 2 times minus times 6x is minus 12x, then minus 2 times minus 33 is plus 66. Then I just delete the brackets and put minus 3. Then I close this one, minus 7. Okay. Now, what should I do here? I should add this together and add the x's together also. So negative 2, negative 5y, 5x minus 12x is minus 7x, and 66 minus 3 is plus 63, then minus 7. Now I will distribute the negative 2. So negative 2 times negative 5y is 10y. Then negative 2 times minus 7x is plus 14x. Then negative 2 times 63 is negative. 2 times 3 is 6. 2 times 6 is 12. Then I put negative 7. The last step here is to add these two numbers together. That's it. And then we're done. So 10y plus 14x minus 7 plus 6 is 13, so 1, 3, 3. Okay. Simplify the fractions. We can simplify a fraction by just simplify the numerator and the denominator of the fraction separately, and then simplify the fraction. For example, here we have 36 over 9. So you know that 36 is 4 times 9. So I cancel 9 with 9. I'm left with 4 and the negative. Also here I can cancel this y with this y and this z with this z. So I'm left with x squared. Of course, here we have to put this condition that the denominator does not equal 0. Okay, we have here how to evaluate the expressions by knowing some specific values of the variables. So if x here equal -2 and y equal -4 and z equal 5, we can evaluate this expression. So all what you have to do here is just to take the value of x and put the -2 instead of. Also here the y we put -4 and z we will put 5. Here x will put -2 and this z will put 5. Be careful if there is negative and power, you have to put a parentheses to include the negative inside the power. So if x equal -2, you put it as this, not as this, because this does not equal. Okay, now we just have to find out -2 to the power 2, which is 4, and we put the rest as it is. Now we will do the multiplication here. So -4 times 5 times 2 equal -40, and the rest we will put it as it is. Now we will do this. 4 minus 40 is -36, and then we will add this together, which is a 3, and then we will times this, which is 9. Then we simplify. 36 with 9 is -4. Okay, so here we have to evaluate the expressions by using x equal -2 and z equal -4. So instead of x, I will put -2. So -2 plus 3 square minus 9. And instead of z, I will put -4. So 6 minus -4. So by following the order of operation, I have to do the parentheses first. -2 plus 3 equal 1. So this would be -1 square minus 9 over. Minus with minus is a plus. Minus times minus is a plus. So 6 plus 4. Now we know that 1 square equal 1. So -1 minus 9 equal over. And 6 plus 4 equal 10. Now -1 minus 9 equal minus 10 over 10. We can cancel this 10 with this 10. I will left with -1. And this is the answer. Inequality simples and absolute values. Now in the absolute values, or first the inequality simples, I can read this as a less than b. Okay? So this simples is read as a less than b, or I can read it from this side, so I can say b more than a. So the value is more when this simples is open to it. But we usually read the statement from the left to the right. So we read it as a less than b, and here a more than b. Okay, we read it from the left to the right. What's this means? It means that A is located before B. This means A located before B. So if we are in the number line, first A, then B. You know that in the number line, when you are going to the right side, the values is increasing. Okay. So as you can see here, we have the left numbers, then we have 0, then all the right numbers. So we can say that 4 is more than 2 or greater than 2, okay? And 2 is less than 4. So how to read these simples? A less than B, and this is A more than B. And this is A less than or equal B, and here A more than or equal B. This one A equal B, and here A does not equal B, and here A is approximately B, approximately equal to B. An example of approximation, that pi is approximately 3.14. If A is a real number, then A is positive if A more than 0. So sometimes we need to put a condition, and usually in the math, we likes to write things in symbols, not in written, in a written sentence. So instead of writing A is a positive, we can write A more than 0, A more than 0. So this phrase means that A is positive, but this inequality, A less than 0, means that A is negative. So what about if I mean is negative and 0 or positive and 0? We use this symbol, this inequality. So A more than or equal 0 means it is positive and 0. And if I write A less than or equal 0, it means it is negative and 0. So instead, we can write, if it's positive and 0, it means it's not negative. It's not negative. Okay? If it's negative and 0, it means it's not positive. So all these expressions means the same things. A is 0, so I write A equals 0. And if A is not 0, I write A does not equal 0. So the number 0 is not positive, neither positive nor negative. So it is in the middle, and it's not counted to the positive real numbers or the negative real numbers. Okay, in this example, indicate whether the following statements are true or false. For real numbers A and B, if A less than B, then negative A less than negative B. So this statement is false, and it is false because if the statement is false, you can just give me an example to prove this statement is wrong. So A less than B, for example, 1 less than 3. But when we times both numbers with negative 1 and negative 3, we can see that negative 1 is more than negative 3. Okay, because the relation with the negative number is different. Okay, so the negative 1 is more than negative 3. So this statement is false. Now, for any real number A, the number negative A is negative. So also this is false, not necessary. If A equal negative 1, negative A equal negative 1, which is 1. And 1 is not negative, 1 is positive. Okay? Okay, let's see the question here. Try and check. Whole numbers are positive integers. Whole numbers are positive integers. Is that correct? You know that in the whole numbers, we have the 0, 1, 2, 3, and so on. Are those positive integers? The positive integers does not include the 0, but here we have the 0. So this is false. Natural numbers are non-negative integers. Okay, you know that the natural numbers is 1, 2, 3, and so on. But the non-negative integers, including the 0 and the positive, right? So here we have only positive, but here we have 0 and positive. So this also wrong. Now, the absolute values of real number x denoted by these. Let's read that absolute value of x is to find the distance from 0 to x on the real number line. So the absolute values is just care about how many units am I far from 0. So 0 here, and I have negative 3 or 3. The absolute values of negative 3 or 3 equal 3. Why? Because I am 3 units away from 0, and here I can be 3 units away from 0. So the numbers could be 3 or could be negative 3. So that's why the absolute values is care about how far am I from 0, or how many units am I far from 0. I don't care about whether I am to the left of 0 or to the right of 0. I care only about how many units am I from 0. Okay, so to evaluate the following expression, it's easy to find out the absolute values if the absolute values, if you want to find the absolute values of a number, specific numbers or known numbers. So the absolute values of 6 equal 6, and negative 6 would be also 6, 0 would be 0. But what about if we want to find the absolute values of an unknown value? So we have to know whether this value is positive or negative. If it's positive, it will be the same. Okay, so that's why the absolute values of negative x, it is so the and x is more than 0, it would be x. Okay, so we will take only the number because it is positive, so we don't have any problem. But the absolute values of x here is negative x. Why? Because it's written that x is negative. Okay, so for example, negative 3. So we can't say that the absolute values of negative 3 equal negative 3. We have to multiply this one with minus. Okay, so that's why we multiply x with negative, because x is negative. So we have to multiply it with negative to be positive, because negative times negative equal positive. Okay. So this that's why we can say this definition. So the absolute values of x is x if it's positive and negative x if it's negative. So if it's negative, as we said before, we have to multiply it with negative. If it's positive, we just put it as it is. Okay, the absolute values is always more than or equal 0. Okay, and we will use this one in solving the absolute values equation in the next chapter. The absolute values of x equal the absolute values of negative x, because both will give us the values of x without the positive values of x. Okay, and as we said, it's care about the distance from 0. We don't care about the direction. The absolute values of x equal 0 if and only if the values inside the absolute values equal 0. Okay. Here we have the following examples. We want to find out the absolute values of those numbers. The absolute values of root 2 minus 1 would be the same. So it would be root 2 minus 1. Why? Because the value root 2 minus 1 is positive. Okay, because this value is positive. Now, how do you know that this value is positive? You know that root 2 is more than 1 or more than root 1. This is obviously root 2 is more than 1. Since root 2 more than 1, so this value would be more than 1 also, more than 0. Okay? So if you don't have a calculator, you won't be able to find out root 2 minus 1. So first things you have to do here is to take off the absolute values. So to take off these absolute values, you have to know what inside the absolute values, whether it is positive or negative. If it's positive, it would be the same. If it's negative, you will times it with negative. Now let's see the b, pi minus 4. So now same things, pi minus 4. You know that pi is approximately 3.14. So these values would be negative because when we subtract two numbers, we take the sign of the large number. And 4 here is larger than pi. So the answer would be negative. So since it's negative, so these values will come out of the absolute values after we times it with negative. So timesing this with negative, we just change the sign of the inside terms. So the would be 4 minus pi. Okay, for C, we can find out the values and then take off the absolute values. It's easy here to find out what is third minus half. Okay, so 1 times 2 is 2 minus, 2 minus 3. 2 minus 3. Then 2 times 3 is 6, which is negative 1 over 6. Now, I can take off the absolute values and take off also the negative sign. So it would be 1 over 6. Now, the difference between A, B, and C, that in A and B, I take off the absolute values first. And in C, I find out the value. I do the operation, whatever it is. Then I take off the absolute values. Okay, because I didn't do that in A and B because I can't find out the exact value of root 2 and pi. That's why I just find out what is the value, whether it is positive or negative. Then if it's positive, I put the value as it is. If it's negative, I times it with negative. Okay, so in the order of operations, I deal with the absolute values as it is, like the parentheses or the brackets. Okay, so same things. Okay, that's all for this lecture. Hope it was helpful. Thank you so much.